We're going to talk about complementary and supplementary angles for how long? 7 minutes, maybe 7 minutes. Guys, what do complementary angles add up to be? Yeah, complementary angles add up to be 90 degrees. So let me just give you a diagram, a weird looking diagram. You'll see this often. I know it doesn't look like a right angle, but you can have right angles like that. I'm going to split this. Okay, this is going to be angle 1 and this is going to be angle 2. You see that? By the way, if I split it like that, does that mean they're equal? Absolutely not. Absolutely not. Angle 1 plus angle 2 equal 90 degrees. Okay? Therefore, these guys are known as being complementary angles. You know what's the easy way to remember that? My cousin showed this to me. Yeah, watch this. Complementary angles form 90 degrees. Yeah. Okay. Good. But we're also, part of the reason for us doing this is so that we can talk about some kind of vocab that you will see later on. Now, these two angles are what? Yeah, angle 1 and angle 2 are angle 1 plus angle 2 equal 180 degrees. These two angles are also called a linear pair. You know why? You see the words embedded in that vocab, Mike? Line, linear pair. A linear pair always form 180 degrees. You'll need that kind of vocab. And these guys are also, these guys are also known as being supplementary angles. You guys are good with that? And supplementary angles, you can put the line there and it forms an 80. We're good? Nice. Now here are the problems on this sheet. If you hadn't seen supplementary angles, we would go through this until you felt comfortable on it, but I don't want to bore you. Here are the problems that you need to become really good at. Do you see problem 18? Do you see problem 18? And they give this kind of notation. They're in a ratio of 7 to 2. So 2 complementary angles in a ratio of 7 to 2. Find each angle. ASOS, what are we going to do, buddy? That's true. That's true. It won't always be the case it'll be that easy. What's the strategy? Ben? Absolutely. Anytime you see this kind of notation, this is a comparison. They're in a ratio of 7 to 2. So 7x plus 2x equals 180. That's their relative weights to each other. Whoops, equals 90. Thank you. There you go. This signifies we do not need to stay on complementary and supplementary angles. You guys are good to go. All I wanted to do is make sure that you know how to do this stuff, this ratio business. Divide both sides by 9, x is going to be equal to 10, and then you sub that back into the problem. You'd get that, the angles equal 20 degrees and 70 degrees. You guys are all good? All good in the hood? Okay, we're gonna move on then. You can put this away. If anybody has trouble with complementary or supplementary angles, you let me know. We'll study from this sheet. If you need any extra practice, you let me know. Yeah, we're moving on. I just had to make sure that basically all of our vocab is there now, and your algebra skills are good, and we can go. Okay, new stuff. Guys. So here's what we're doing. Let me brief you on like how our course has gone so you can adjust it in your minds. First we talked about some vocab, right? And then you weren't quite sure how all the vocab fit together, so we took a detour. We started to explore triangles. We practiced for a little while. We learned some theorems about triangles like biggest side opposite the biggest angle, things like that. Then we took another detour. We learned about isosceles and equilateral triangles. Now I've showed you like complementary angles, supplementary, and now we're ready for proofs, just triangle proofs, okay? We're going to do quadrilaterals come next. We're going to learn everything there is to know about quadrilaterals, and then we're going to prove stuff about them. Okay. But before we begin with proofs, let's talk about a little bit about like grammar skills in geometry. You have seen sometimes, and should be on your sheet, that we put a bar over the two letters. You know, when we talk about a line, you put a bar over it when you don't know its length numerically. You know what I mean? Like if you're just telling me that these two segments are congruent to each other, put a bar on top. But if you're telling me that these two segments are 9 inches long, take the bar off the top. Okay? All right. Also with angles, okay? If you talk about two angles being congruent to each other, but you don't know their actual degree amounts, you just put this, angle ABC. But if you know that both angles are 37 degrees, you put a little m in the front of it. All right? Okay. Let's go on some more. When to use the congruent symbols and when to use the equal symbols. This comes up in proofs. If you know the measurement or the size numerically of things, use the equal sign. If you're just talking about them being congruent to each other, right, use the congruent symbol. All right? So equal numbers, congruent, same size. Now, you will have to know all of these properties. I could have written them down one by one. That turns out to be extremely boring. Extremely boring. So I want you to take 2 or 3 minutes and just read them. And then we're going to go over them. Don't worry. Take it 2 or 3 minutes, just read through them, see if you understand what they're talking about. They're really easy ideas. So you've read through them. Is there anything in there that seemed a little like crazy? Shoot, Jenny. It's basically if you got the same amount of stuff, right, and you add something equal to both of them, they're in separate pictures, you still have, those two quantities are still equal to each other, okay? Same thing with subtraction, division, multiplication. You'll see it in action. What's up there? It is the chain rule for proofs. So that's its translation. Very good. Way to pick that up. What about did everybody kind of get the partition postulate or no? The whole equals the sum of its parts. So if you have a line segment A, B, C, AC is equal to AB plus BC. Okay, it's the whole. What's up, Sarah? So if two things are equal, you'll see it in action, right? I'm telling you that, like, oh, I don't know. Follow along in your head if you can, right? A is equal to B, right? That means anywhere else you see A in a problem, wherever it comes up, you're allowed to sub B. And your like explanation for why it is you're allowed to do this, your justification, you just say substitution, man. Substitution. Good? Let's practice. Flip over your sheet. Okay. These are simple one-step things. Ultimately, they're going to lead up to proofs, which are 10 steps. And this may be one step of a proof, so you should get used to seeing it. I know it's a little blurry on my board, and I apologize for that. On your paper, does everybody have notes? Everybody has a clean sheet of paper out? Take a look. You are given line segment ABC, so just draw a picture of it. Here's A, B, C. How could you possibly prove that AC is AB plus BC? What postulate allows you to prove that? Shoot. Close. Mike. Partition postulate. The whole equals the sum of its parts. You could say partition postulate. And when it comes down to saying postulate or property, we're not going to make a big deal of it. Partition postulate, or you could say whole equals sum of parts. Since you guys are the honors class, I would really rather that you use this. It's more formal. It's more like elegant. But if you are stressed for remembering vocab and words, this is also appropriate and people will understand what it is that you're saying. Here's 2. Try and draw a picture of that. Given that AB bisects BAC and that EH bisects angle FEG, and that BAD is equal to FEG, how could you prove that other one? Oh, it's crazy, right? Who knows what the hell anybody's talking about? You should just draw a picture. By the way, this is on the back of your sheet, in case you're wondering where this is located. Okay? It's hard to see. I just tried to put it on there to save paper. So let's just draw a picture. Here's AB. You know what? I'm not even going to put arrows on the end because that would be wrong. Here's BAC. And it's saying that A. I messed up. See, that's why I have to read. I got some angle, and it's BAC. What's up? What's up? Oh, interesting. Well, that's annoying. You wrote in pen? Don't worry. Hold on. Let's take a pause. Let's think about it. This problem cannot be solved. They messed up. It's okay. Guys, let's do this one. So we got AFB. I've done that before. Gone through and changed things. If it starts getting messed up, we don't fix it. Now, I don't know if F and G are in the same spot, but AF is equal to CG. Oh, they are. They're like the same size. And FB equals GD. How could you prove that AB equals CD? How would you go about doing that? I think it's going to take a few steps. Dale? You know, the addition postulate only really gets used if we are adding something to it. Like adding something to something we already have known. Maybe. No, I hear what you're saying. I've done this. Mike, what are you thinking? Yeah. You know, I've done this a whole bunch of times. I happen to know that here's what I use in this. If you were going to use the addition and the other ones, you'd have to show me. What I would say is that AF plus FB equals, it's congruent to AB. Is that true? And that CG is plus GD is congruent to what? And this is all by partition. What's up? Are you good? What's up? Hold on, we're not done yet. We still have more to go. Okay, talk to me. Oh, congruent. Yeah, we don't know the numbers. That's why we use that. But the congruent symbol really means equal without a number. Yeah? Now, here's what I'm going to do. True or false? You guys tell me. Can't AF be interchanged with CG? Don't they mean the same amount? What about FB? Can't it be interchanged? Watch what I'm going to do. I'm just going to take these two, CG plus GD, and I'm going to switch them out. Isn't that the same thing? Isn't that congruent to AB? Substitution. And we could do AF plus FB, right? I subbed them out. That's all I did. To CD, this is substitution. Does that make sense? Well, I mean, if that's true, can't I also now sub these two, make these two equal to each other? Yeah. I'm just going to use it again. What do you mean? Why is that? Why is it substitution? You tell me. You tell me. You tell me what other rules that we have, right? We have addition, we have multiplication, we have subtraction. I'll give you a reason why it's substitution, at least for me in my own particular logic. This was partition. I took the whole segment, I broke it up. Okay? Then in the directions, it told me that like each one of those little individual broken pieces was kind of congruent to another piece that was separate from it. You know what I mean? So I switched them out. Okay? And it turned out that CG plus GD equals CD. Yeah? And that AF plus FB equals CD. If that's true, right? If this, just this part, Lisbeth, all I did, right, is take this quantity right here and sub it out for this. Do